Hi everyone, myself Dr. Lakshmi Prasad, working as an associate professor in the Department of Data Science in Institute of Aeronautical Engineering, Hyderabad. In this video, I'm going to discuss about some of the basic concepts on basic mathematics and probability for data science. So, very first thing is that what is a matrix? So, matrix is nothing but a set of elements, so which is going to be organized in the form of rows and columns, and the rows is nothing but uh, where you can able to access through row wise, and you can also access the item through column wise. So here A and D should be the diagonal elements, and B and C what we call it as the off diagonal elements. So the matrix like plane in many ways, so they can be added or can able to be subtracted, or can also be multiplied, and you can also perform division. Suppose if I'm going to have a matrix like this, and I'm also going to have another matrix. So if I'm going to perform the operations like addition, multiplication, subtraction, and division, so we have to know what are the dimensions of the matrix. If the number of rows should be divided by number of columns, so what should be the dimension of the matrix A? So I have to write it as number of rows by number of columns. So here it should be 2 rows and 2 columns. There should be 2 by 2 matrix. And here we are going to have only 1 row, and but we are going to have 3 columns. So that should be 1 by 3 matrix. So in the matrix with only 1 column, or 1 row, you can able to call it as a vector as well. So if a matrix is going to have an equal number of rows and equal number of columns, so it is called as a square matrix. So usual notation should be uppercase letters should be for matrices and lowercase letters should be for vectors. So this should be the normal convention to be followed for representing the matrix. So in matrix multiplication, so the conformability of mat conditions should be considered. So it should also lead a matrix, but should be also equal to the raw matrix. If A is an M by N and B is an N into P matrix, so how the product is going to be? That means that so here uh, A is the set of values and B should be the another matrix. So how the product of A and B have to be performed here. So that means so the first row of the first matrix should be multiplied with the first column of the second matrix. Okay, so how the multiplication is going to perform here is so the row of the first matrix should be multiplied with the row of the second column of the second matrix. So how can you write? So A11 into B11, A12 into B21. Similarly, the same thing is going to be applied to the second matrix. So the first row of the first matrix should be multiplied with the second column of the second matrix. So A11, B12, and B12, B22. And similarly, the same thing is going to be applied for the next one. That should be A11, B13, and A12, B2. So these are the dimensions of the matrix. So when I'm going to say that the matrix multiplication addition is going to possible ways, so the column of the first matrix should be matches with the row of the second matrix. So if these two are same, then only the matrix multiplication division everything is going to be possible. And next one is the transpose matrix. So transpose of the matrix is going to be represented as A power T, and formally we are going to have inverse of the matrix as well. So this is the complement of the matrix. So if I apply the one for the complement of that matrix, we can able to get the original matrix. So see here, so what should be the transpose or complement we can able to call it as. So if I'm going to have the matrix like this, so once I apply the complement or transpose of this, so all the rows become columns here. So a transpose should be 1, 2, 3. So see in this example, so here I'm having a matrix like this, so it should be of 2 by 3 matrix. So after complement or after transpose, the row becomes column. So that should be the transpose of the matrix. Our next question is that, so what are the different types of matrices? So we're going to have some of the different types of matrices like identity matrix and null matrix. So identity matrix is the matrix whose ones along the diagonal and zero should be everywhere. So identity means whenever we're going to have all the diagonal elements should be one, then it should be called as identity matrix. And similarly, null matrix means if all the elements is going to be zero only, then it should be null matrix. So both that should be the symmetric. So A equal to A transpose, and example of idempotent like this A square and then A cube like this. And next we'll order the different types of matrix operations. So in this one, so we'll have some of the operations like addition, subtraction, multiplication. So if I'm going to have matrix of 2 by 2 and this is also 2 by 2 matrix, we can able to perform. Just add the numbers of each and every corresponding element of the matrix. So A plus C, B plus F, C plus G, D plus H like this. So we have to just add. So in similar operation, we can also perform the subtraction as well, but the multiplication is going to be somewhat changed. So how this one, the first row of the first matrix should be multiplied with the second row of the first matrix. So AE, BG, and same thing AF, BH. Similarly, the same thing CD into EG, and then CD into FH. And similarly, you can also multiply the matrix with the scalar value, like if I'm going to have a matrix, so Ka, Kb, Kc, K. See how the matrix 1, 2, 3, 4. I want to multiply with 1, 2, 3, 4. So how the matrix multiplication is that, so 1 into 1 plus 2 into 3. Next one is 1 into 2 plus 2 into 4. Here 3 into 1 plus 4 into 3. 3 into 1 plus 4 into 4. So like this we can able to perform the matrix addition subtraction operations. So see the example. So here going to have matrix addition. So this is the matrix we have. So simply adding the numbers 2 plus 3, 1 plus 1, 7 plus 0, 9 plus 2. And matrix subtraction is the 2 minus 1, 1 minus 0, 7 minus 2, and then 9 minus 3. And matrix multiplication, so 2 into 1 plus 2, 1 into 2. So that should be 4. 2 into 0 plus 1 into 3. 3. And scalar multiplication, so I'm applying 1 by 8, it should be divided with the matrix. So 2 divided by 8, that should be 1 by 4, 1 by 2, 6 by 8, it should be 3 by 4, and 1 by 8. And discuss the different laws of matrix. So first one is that commutative law of matrix addition, that means A plus B is equal to B plus. So commutative law. Suppose if I am going to have a matrix like this is the A matrix and B matrix. So addition should be A11 plus B11, A12 plus B12, A21, and then B22. So same thing if I am going to add in reverse direction like this B plus A. So B is this and A is this. So if I am going to add it, B11 plus A11, B12 plus A12, B21 and B22. And next one is distributive terms. So what should be the distributive means? So A into B plus B can able to return as AB plus AC. That should be the distributive law across. And matrix multiplication. So if I'm what the operations we commutative and distribution apply on matrix multiplication, that should not be applicable. Suppose if I'm going to multiply with A matrix with B matrix, it should not be equal to B into A. Okay, so similarly see the example. So we are going to have values like 1 2 3 4 and 0 minus 1 and 6 7 should be the matrix B. If I'm going to multiply it, I'm going to get the values 12, 13, 24, 25. Similarly, if I'm going to write b into a, if I'm going to get this value. So this should not be equal. So a into b should not be equal to b into a. Commutative law. So AB equal to BA whenever it is possible is that, so whenever the B should be a scalar, or B should be an identity matrix, or it should be inverse of A. So theorem is that, so if A equal to AB equal to AC, then we have to prove that it should be B equal to C. So if AB equal to AC for all the matrix A, then B equal to C automatically. So inverse of the matrix. So if I'm going to have a matrix like this, if I'm going to write how the inverse of A, so if I'm going to A into I, then should be automatically A only. And so given a matrix A, which should be of size n by n, and B should be n into n, so it should be right inverse of A. That means if and only if A B equal to I n. So similarly, if I'm going to have m into n, and then matrix should be m into n left inverse, so then it should be C is equal to I. Discuss briefly about vectors. So here a vector is nothing but an object with both magnitude and direction. So for our purpose, the vector is nothing but a one-dimensional array which is going to represent a sequence of values. So generally it should be represented by using an arrow mark or a bold font, and the vectors can also be broken into components which are individual members of the vector. Suppose if I'm going to have a vector like this, and it should be called as x1. So what is the value of x1? It should be 3, and x2 equal to 6, and x3 equal to 8. So how can I able to write this code in Python programming? So like import numpy as np. So np dot array. Similarly, we are going to have example like suppose we are going to have average satisfaction ranging from 0 to 100 of employees for the three departments of the company. So 57 for HR and 89 for engineering and 94 for the management. So how can I able to represent this in the form of the vector? So for this I have to create a vector, and x1 value is treated as 57, x2 should be 89, and x3 should be 90. And next one is that arithmetic symbols. So what are the various arithmetic symbols in we have? So for that summation, that means uppercase sigma symbol is the universal symbol for addition. And for example, if I'm going to create a representation of the vector, so x is equal to 1, 2, 3, 4, 5. In order to find the sum of the content, we are going to use the following formula. So mean equal to 1 by x into sigma xi, and in Python we're going to use the following formula, like sum of x is equal to 15. So if I'm going to have a vector of length, then the mean vector of I'm going to calculate as follows. Proportional, so is under one. So proportional means so where the lowercase alpha symbol is going to be represent that. So it should be proportional to each other. And this means that whenever the value change, other also going to be changed. Like uh, the direction in which the value moves depends on how the values are going to be proportional. And values can either directly and indirectly can able to do that. Suppose we are going to consider an example like suppose the sales of the company vary directly with the number of customers, then I can able to write sales directly proportional to the customer. Similarly, the prices of gas is going to be increasing constantly along with the oil, then it should be called as a proportional. The next one is that the dot product. So dot product is like an operator which should be like addition and multiplication. Normally, it is going to be used to combine the two vectors, like 3, 7 is one vector, 9, 5. So if I'm going to apply dot product, so 3 into 9 and 7 into 5. So that is the dot product value. Suppose we are going to have an example. So consider that we have a scale of 1 to 5 for a customer who love comedies and hate romantic movies. null right with the action was. So in this, if I'm going to rate the scale like 5, 1, 3, so this should be considered as vector. If I'm going to consider as another vector, also have to be taken out. And next one is graph. So graph is nothing but a Cartesian graph. So should be lies on x and y coordinate. And here we're going to be referred to the variable x variable being dependent on independent variable, and y should be the dependent variable. Suppose if I am going to have a 2 points, then how can I able to represent this? So x is the one axis and y is another axis. If I'm going to represent a point, I can able to specify x comma y, and then another point if you want to specify x to y2. Now the slope of these 2 points is going to be written from the equation. Slope m is equal to y2 minus y1 by x2 minus x1. And next one is that logarithmics and exponents. As an exponent tells you how many times you have to multiply the number itself. Suppose 2 power 4. So x4 is the exponent here. So that many number of times we are going to be repeated. And logarithmic, so here this is the base value and this is the logarithmic value. The next one is that discuss briefly about the set theory. So here the set theory is going to be involve so many mathematical operations at the set level. It is sometimes act as a basic fundamental group of theorems that governs the rest of the mathematics. So for our purpose, we are going to use set theory in order to manipulate the group of elements. In Python, we are going to have a function like set of functions. So by making use of the set of function, we're going to create the sets. So S is equal to set of 1, 2, 3, 1, 2, 2, 3, 2, 1, 2, 2, 3, 2. And instead of repeating the same random numbers, the set is going to be presented as 1, 2, 3. So how this magnitude of the set can be defined? So it should be the number of elements in the set and is going to be represented as follows. So mod A is equal to magnitude of A. And if we want to wish to denote the element with the set, so the 2 belongs to this. And if I'm going to have two sets like A equal to 156, 156 and B is equal to 5, 1567. So by seeing this, the values of 156 already exists in B. So it should be called as a subset of B. And next one is that discussing briefly about the set theory. So what is the set? So set is a well-defined collection of distinct objects, and objects in the sets what we can able to call as the elements of the members of the set. Normally we are going to use the capital letters to denote the set and lowercase letters in order to denote the elements of the set. So what is the empty set? So set with no elements also called as a null set and should be defined as a symbol I. An empty set means the set with no elements is called as empty set, also called as a null set. It should be denoted by the symbol. And finite set is the one which can be counted, whereas infinite set is the one which cannot be counted. So example, so the set of two distinct positive integers has 90 elements, whereas the set of integers multiples of 5, which should be infinite set. So next one is that cardinality of the set. So cardinality of the set you can able to define as the number of elements that are present on set A. Suppose if I'm going to have a set like 1, 2, 3, 4, 5 like this. So the cardinality of A should be 5. So the number of elements that are present in the set will be treated as the cardinality. So for the infinite set, it should be infinity. And next one is that, so explain briefly about the Venn diagrams in the set. So this should be the universal set you can able to present as U, and here is the set of this universal set. So represent as disk inside the regular polygon region. And some of the possible Venn diagrams of the two sets will be union and then subset. Union means that it should be the elements which are present in set A and set B. And then intersection means The elements which are common in set A and set B. If I'm going to write like this, so that B is the subset of A. So A intersection B, A union B, all the elements that are present in set A and set B, and A should be subset of B. So how the complement of the set is going to be represented? So the complement of the set should be represented as A, or so it should be the complement. So complements means the elements which are not present in complement A should be treated as the complement of the set. So this shaded region represents the complement of the set. And next one is the union of two sets. So union means the elements which are present A as well as in B should be treated as union of two sets. And next one is intersection of two sets. So the elements which are present in set A and set B treated as intersection of two sets. And the sets formed by the two sets will be, so R1 is equal to A intersection B complement, R2 is equal to A intersection B, and R3 is equal to A complement intersection B complement, and R4 should be A intersection B complement. And this will do some basic counting rules. What I'm going to follow is, so N of A union B can be calculated. That should be as N of A plus N of B minus N of A intersection B. And similarly, A intersection B complement should be written as N of A minus N of A intersection B. Okay. So by seeing this, we're going to have some other examples, right? So suppose A is equal to 1, 2, 3, 4, and B is equal to 1, 2, 5, 6. Suppose if I'm going to write A and B, the elements which are present in set A and set B already one to this is going to be present. That means here I can write it here is, so 1, 2, and set B should be 1, 2, 5, 6. And similarly I can write A intersection B. So the elements which are common in set A and set B, that is 1. So this should be the intersection part. So which is common in set A as in set B, and the elements, rest of the elements should be lies on them. And similarly, if I want to have, suppose the value should be A is equal to 1, 2, 3, 4, and B is equal to 1, 2, 3. How can I able to calculate A union B here? So A and B means a number of elements would be 4 plus number of elements in B 3, and number of common elements that present in set A and set B 2. So 7 minus 2, that is. And next one is that explain briefly about the vector and the matrices with an example. So vector is sometimes collectively called as an object which should be easily referred, and the position of the me on this floor can be described by two numbers. So I can able to write it as vector 12, 3. Suppose I eat 2 eggs, 3 slices of bacon, and 2 slices of toast for breakfast. So my basket is going to be present in the form of a vector, means that, so B is equal to 2, 3, 2. So here 2 should be eggs, and 3 should be 3 slices of bacon, and 2 should be 2 slices of toast. Suppose we're going to have another example. Suppose we're going to have x of dollars, $1.39 per dozen, and bacon costs $2, $2.49 per pound, and bread costs $1.99 per leaf. So assume that a pound of bacon has 16 slices. I will offer that, and what should be then the price in the form of unit of take cost, how it will be. So since the x cost is $1.39, should be divided by 12. So this is one value, and 2.49. So per pound, and the bread cost also this. So matrices. So in other cases, uh, the number naturally lies up in arrows. Okay. So this often able to pause to find number of objects, and there should be a corresponding number of each pair of objects. Suppose we are going to have example like this. So pancakes, bean jets. So these are the three types of breakfast, and the ingredients are going to arrange like this. So flour, water, milk, and oil, eggs. And for pancakes, so I need 1.5 flour, 0 watt, 1.5 milk, 2 cups of 2 pancakes of egg, and 3 oil spoons. So the same ingredient should also be applied for creating for preparing crepes. So it should be half flour, 1/4 water, half milk, 2 eggs, and 2. So how can I able to define this matrix? So matrix is nothing but a rectangular array of m elements which is going to be arranged in m horizontal rows and m vertical columns. So here the matrix is that, so A11 and A21 so on A11, A12, A22 up to so on AM2. Like this we're going to create the matrix here. So here we're going to have rows and columns in the matrix. So this should be the row of the matrix and this should be the column of the matrix. So dimensions of the matrix should be write it as number of rows by number of columns. So example, package strip is 5 into 3. So vector is n by 1 or 1 into n matrix. So here I'm going to write it should be 0 1 and then 0 0. So algebra of matrix. So my wife does not like x, so the breakfast my take should be 0 to 2. So does not like them, this should be the quite on. And next one, algebra of vectors. So that means you can able to perform addition, subtraction, or also on vectors. Suppose I'm going to have the sum of two n vectors is the vector. So ith element is going to be the sum of corresponding ith element of the first vector. So example you take, suppose I eat a breakfast every day. So what vector is going to present my consumption over the week? So for this the vector is 7.2, 7.3, 7.2. So the value should be this. Okay. And the scalar multiple of the vector is also called as scalar. It should be of vector whose ith component is the type of ith component of. And linear algebra of matrices. So here the matrices can also be added and scaled. So if I'm going to have a matrix like this 2 by 2 and another 2 by 2 matrix, if I'm going to add it, so 2, 1, 3, 6. Like this you can able to add. So the scalar multiplication can also be possible. So I'm going to multiply the 4 value with matrix element. And next one we discuss in briefly about the compound events. So events that occur as a single point or sample space is known as simple event. For example, if the probability of getting 3 when the die is tossed. Okay. So for S is equal to 1, 2, 3, 4, 5, 6. And if E is the event of getting the 3 when the die is tossed, so what is the probability that? So the probability of getting a 3 when I'm going to die is going to be tossed. So that means the die is going to have values 1, 2, 3, 4, 5, 6. So the event is that what is the probability of getting the event, getting an even number 3 when die is tossed means. So 3, and what is the probability of that event is 1 by 6. So how many number of 3s are there? 1 out of 6. So what is the compound event? So compound event is the event that has a more number of possible outcomes. So in a compound event, an experiment able to give us more than one possible outcome, and these outcomes may be have different properties, but they are usually equally possible. So if an event occurs more than one point, then it should be considered as a compound event. And this compound event are a little more complex than the simple events. So the total probability of occurrence for all outcomes of the compound event should be equal to. So the formula is that first we have to find the probability of each event occurring, and then we'll be the possible probabilities together. Suppose if I'm going to have an even number, so what is the probability of getting an even number on a die? So what is the probability of getting an head? So compound event is an event that combines two or more multiple events. So given that events will be A and B, so the probability that A and B occur is that's the probability of A intersection B, and probability of that is either A or B means probability of A union B. So let's say that the universe should be of 100 people. So we have showed up for an experiment, and the new test for cancer is being developed. So in preceding diagram, so the red circle A represents the 25 people who actually have a cancer. So using the relative frequency approach, the probability of A should be the number of people with cancer. So that is 25 divided by 100. So let's introduce the second event called B, so which contains people whom the test may be positive. So let's say this is 30 for 30 people. So the probability of B should be 30 by 100, that should be 3. So that means that there should be a 30% chance that the test is going to be positive. So look at this diagram. So this should be the representation of compound events. So here I can able to represent a compound event A, and there should be the intersection of A and B, and there should be the under. Suppose see that the probability of A and B is equal to 20 divided by 100, that should be 0. That should be 20%. And if you want to say something that someone has a cancer or the test came back positive, so similarly this would be the total sum of the union of two events for people. So that 30% of people either have cancer or maybe going to have positive outcome. So discussing briefly about the compound events. So in this one, I have to present the conditional probability. So the probability that have a cancer you can able to call it as the probability of A, and the conditional probability of A given B can able to write it as probability of A by. So effectively, if I want to ask the calculate what is the probability of the event already happened, so I have to calculate like this. So this the entire thing should be the universal set, and this should be the B and probability of B. Suppose we're going to have a formula for calculating conditional probability. So the probability of A by B can able to write it as probability of A intersection B divided by P of B. So then the values if I'm going to substitute it, then it should be able to get it as the result. That should be 66%. So in a group, we are going to have 100 sports car buyers. So 40 bought alarm sets and 30 bought bucket sheets, and 20% purchased alarm system and bucket seats. So in step 1, what we're going to have to be lateral setting alarm system and figure out P of A, which is going to give a question of 40%, that should be 0.4. And B is selecting the bucket sets. So how can able to figure out the probability of A intersection B, and how to substitute the values in the equation P of A B by A equal to P of A intersection B divided by P of A. That is 0.2 divided by 0.4. That should be 0.5. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.